We're going to talk about something in this video called odd and even trig functions. And to do that, we need to review a little bit. Okay, so you may or may not remember what an odd function is or an even function is. The idea is that a parabola, specifically this toolkit parabola, x squared, this is an example of an even function because it's symmetric about the y-axis. So there's a lot of different even functions. But the main thing is that all even functions have this symmetry. So this is another example of an even function. Cosine of x is another example of an even function because it has this symmetry. We haven't talked yet about the graphs of trig functions yet, but getting a little into it. But any function that is symmetric about this y-axis, this orange line, is what's known as an even function. Whereas an odd function is something that is symmetric about the origin. Okay, it's a little hard to. That's a little harder to graphicalize, but it means it's symmetric about the pink dot. If I have a point up here, well, if I reflect this, it bounces to another point that's also on the graph. Okay, so x cubed is an example of an odd function. 1 over x is an example, right? Everything over here, if you bounce it across that pink dot, is also on the graph. Another example is going to be something like the sine of x, right? Anything up here, you bounce it across the origin, and it's still on the graph. Here, bounce it across the origin, still on the graph. And there's a couple of ways of thinking about these in general. We'll talk more about the graphs of these trig functions in next chapter, actually, in chapter 8, I believe. But in the meantime, that's what odd and even looks like graphically. That's more a conversation for another time, but gives you a little bit of insight into where this is coming from. So we're just going to start with a property. We'll show in a future chapter where this property comes from. But in general, sine of x, tangent of x, and their reciprocals. So cosecant of x and cotangent of x are odd functions. Talk more about what that means right below. The only even ones are cosine of x and secant of x. Okay. So as a reminder, odd functions. So we showed what it looked like graphically, but analytically with numbers, that means that if I have a negative on the inside of a function, that's the same as a negative on the outside of the function. And even functions, if I have a negative on the inside, it means nothing. It goes away. And there's some cool talk about like connections with this definition, with the graphical definition, but we don't really have time for it here, but it has to do with function transformations and reflections. If anyone remembers that from pre-calc 1 or college algebra. But in the meantime, this is what we're going to be working with right now. So what does this translate to, right? This means a negative on the inside is a negative on the outside since sine is odd. Let's do some examples and get some practice using these. We'll do more of these as well in the identities chapter later on. So example number 4 says, let's do part A. If the secant of some angle t is equal to positive 2, find the secant of negative t. So the negative on the inside does something different depending on whether it's odd or even. So first things first, let's find secant here. Secant, cosine, and its reciprocal is the only even one. Everything else is odd. So secant is even. This right here is even. That's good to know. And for even functions, a negative on the inside goes away. So because it's even, that says this is going to be the same as the secant of positive t. And we just said that the secant of positive t is equal to 2. So that's our answer. We're just simplifying using these properties. In part B, it says if the cosecant of t equals positive 2, find the cosecant of negative t. Oh, we're just going to do the same thing. Cosecant up here, the property says cosecant's odd. So what does odd mean? Odd means a negative on the inside is the same as a negative on the outside. So we have this, negative on the inside becomes negative cosecant of t. And again, cosecant of t is 2, so this becomes negative 2. Right? The negative is still there, and the cosecant transforms into a 2. Because they are equals. They are equal. And if something is equal, that means we can replace one or the other. I'm going to become a ghost again, so I don't block this math. And that's this whole video. Let me know if you have any questions.